Okay, as Dee Ann mentioned, this presentation is, I guess the other thing I should say, is a privilege to be here. This presentation is based on a project that was initiated in 1994 by Dee Ann, Jim Stevens, and Margaret Stevens. It was initially directed towards the upper part of the San Vicente member. Only the lowermost part is shown on this slide. And basically, Dee Ann identified...
The member is the upper member. The Boquillas Formation is divided into two members, as you can see on this. I guess you may come to that, but we need to tell them this is the Boquillas Formation here. I'm going to put interruption. Here is Coastal.
Okay, Dee Ann identified in various places the Allocrioceras hazardi zone, which is shown by the little yellow lines going across this particular cliff exposure along Tornillo Creek. The Rio Grande is right on the other side. The place in the distance here, this is in Mexico. So you're looking right across the river into Mexico.
This is not the Rio Grande.
This is Tornillo Creek in the foreground.
Rio Grande's behind this cliff. It doesn't look a lot better.
Okay, I became involved in this project after working about 25 years in a thing called the Stillwater Complex, which is an ultramafic to mafic layered intrusion known for its platinum, palladium, chrome, copper, and nickel resources. And I will say that stratigraphy, whether it's in a mafic layered intrusion, ultramafic to mafic layered intrusion, or marine limestones in Big Bend, it's basically the same. You have to find a marker horizon and then stick to it. And I will say that there aren't many fossils, though, in Archean age ultramafic to mafic igneous intrusions. Okay, and I will say of all the areas that I've mapped over the time, the Chihuahua Desert in Big Bend has been one of the most challenging sort of things that I've had to do or tried to do. I learned to really enjoy being in the desert. The Stillwater Complex, if you're familiar with southwestern Montana, is just north of Yellowstone National Park. It's 5,000 to 12,000 feet above sea level. The first question, let's go on. This is basically some of the work that we've done over the course of the past 20 years. I hate to think about those 20 years, but anyway. And some of the publications that Dee Ann has mentioned. The first question I'm sure all of you have is, what the heck is an Allocrioceras hazardi?
Except the first, probably the primo student back there from University of Houston, right? You know exactly what it is, right? Yeah, she did.
This is an excellent specimen, and it's a very loosely coiled ammonite. The only living descendant of the Ammonites is the Pacific chambered nautilus. So that's the only known ammonite that's still in existence. So in this specimen, you can see the raised, what are referred to as the raised ribs. And these have sort of spines that project off of the raised ribs. And then there are sort of more subdued secondary ribs on the calcite portion of the shell. And if you're into these types of things, this is what's called the Frag Mikone. This was sort of empty areas behind where the body was that were sort of filled with gas. And if you go beyond the Frag Mikone and you sort of follow it around, you can see it. It's there, but that is what's referred to as the living chamber. And this is thought to be where the critter sort of moved in and out of its shell, so to speak. You can see a few outlines of the shell. There are a few raised ribs on the living chamber area, but usually there are no secondary ribs and there's no spines usually. So this is what an Allocrioceras hazardi. The shape and appearance of the actual living specimen, very loosely coiled and helical in general. So the shape, and it was sort of spun, sort of like, think of a spring, it sort of went down like this. And so basically one of the problems with understanding Allocrioceras hazardi zone is nobody really knows how they moved around. And basically it's thought that because of the sort of helical nature of this, that it couldn't move laterally, that it could only move up and down in the water column. At least that's the general, what a lot of people think, not
If
everyone.
you look at the scale, they're not gigantic.
And the other thing about heteromorphic ammonites, and these were sort of floaters or swimmers. They were nectonic in nature. They were not bottom dwellers for any length of time. The global setting for approximately 94 million years ago, this is at the time of Oceanic Anoxic Event 2. And basically, oceanic anoxic events represent very brief periods in time when global warming was extreme, and you had tremendous amounts of organic carbon being deposited in all settings in all ocean basins, whether from the continental shelf to the deepest ocean basins. There was organic carbon that was being deposited. And there's actually been 4 of these during the Cretaceous, and basically this is set up to be what Oceanic Anoxic Event 2, about 94 million years ago. And the currents, which are shown in red, are my best guess. And also the equator, 94 million years ago, is shown. So the Big Bend region was basically in a tropical or equatorial climate during much of that period, and then onward.
Covered by the western interior.
Yes, and this is that's the western interior seaway.
And over here is
And
the
the
Maverick Basin.
And I should say that the red arrows here represent what people think the surface current pattern is. Whether or not there were any deeper water current patterns in the Cretaceous oceans is highly debatable. There's points on all sides here. Okay, the area that we focused on is the little yellow area here, which covers much of the southern part of Big Bend region in Trans-Pecos, Texas. We think, based on work by Goldhammer in 1999 and in 1999, as well as other work, that similar conditions may have been present in the Coahuila Block area. And the black lines represent faults that were present during the initial rifting of this area, the Big Bend region, the Rio Grande Rift, if you want to think of it that way, although the Rio Grande Rift is a much later feature. And the faults are shown in black here that sort of bound the Coahuila Block, as well as bound the southwestern side of Big Bend National Park. In the black dash line is the Cupido, again, I'm sorry if I blew it, Cupido-Sligo margin. Okay. And the more recent Edwards, Stewart City, Santa Alita, Georgetown, Del Carmen margins is shown in the red dash lines. And so we think that basically I guess you'd call it upper lower Cretaceous margin of the Georgetown and everything, that this heavily influenced a lot of the things that were going on, not only in the Big Bend area, but also in the Maverick Basin area, located about 170 or so miles away.
I guess
And the other sort of structural features that are...
there's no oil out here, though, as much as you'd like
there would, if it wasn't for the tertiary igneous activity, there probably would have been.
in Mexico.
The San Marcos Arch, over which the Eagle Ford Formation thins.
Where's that cross section?
Go back, right? No, not till the end.
Okay, never mind.
Okay, the Maverick Basin. The other feature that I think I was talking with Terry about maybe a little bit was the Tyrell Arch just west of Del Rio, along Highway 90, where a lot of people go to look at the surface exposures of the Eagle Ford that they're drilling in the Maverick Basin, okay, to see the at least equivalent. But basically the Boquillas Formation thins over the Tyrell Arch also.
Oh, here's the arch right here.
Trans-Pecos, Texas is that part of Texas that is west of the Pecos River, and the principal study area is located in gray in the Big Bend National Park.
He did all of this, I did that.
And the quadrangles that were mapped and are available now from the Texas Bureau of Economic Geology, the Solis, and there's 5 of them in there. And
they come as a set.
They come as a set, and there's cross sections too in that set. Highway 90 forms the informal sort of northern boundary of the Big Bend region. This is where you have the exposures of what's called the Boquillas flags. Other people call it the Eagle Ford, but basically it's lateral equivalent to what's being drilled in the Maverick Basin area. And these have been visited by a number of people in field trips over the years. Locke and others. Of course, Langtree, which is sort of right where the Boquillas flags poke out right there at the junction of the Pecos River and the Rio Grande. This was made famous by Judge Roy Bean, who proclaimed himself to be law west of the Pecos in the 1880s and 1890s. And he was portrayed by Paul Newman, and I hate to say this, it was a 40-year-old film, The Life and Times of Judge Roy Bean by Paul Newman. The other fairly more recent type where this Sanderson to Langtree formed the setting was, if you've read the book No Country for Old Men. The setting...
And all that stuff in the book and the movie are true, and it all happened, right?
Tommy Lee Jones portrayed the sheriff of Tyrell County. The county seat is in Sanderson. And who's the other one? Woody Harrelson played one of the bounty hunters in that movie, which was made in 2007 or something.
The book is even
The
scarier.
opening of the book mentions what's called the Desert Air Motel, which is in Sanderson. It's a real place. We have stayed there.
For years.
We've stayed there on a number of occasions. Okay, lithostratigraphy of the Boquillas Formation. The lower Ernst member is shown in green here, in various shades of green. It is laterally equivalent to the Eagle Ford Formation. And the upper part of the Boquillas Formation, the San Vicente member, is laterally equivalent to the Austin Chalk. In Big Bend, there are subunits, informal and basically all informal subunits that have been identified. In the Ernst, the sort of various shades of green that you see separated by dashed lines, these basically represent different ratios of carbonate limestone layers to shale layers. So it's just basically done based on a rolling proportion. The upper part of the Boquillas, or uppermost part of the Ernst anyway, is basically mainly carbonate mud shale and very few limestone layers. The overlying San Vicente member, the base of each one of these sort of 3 units, is made up of massive limestone marl chalk units, and the upper parts, 1B, 2B, and 3B, are basically carbonate mud shale. And we'll sort of develop that as we go along again. Within the...
Question on that last slide.
Yeah, within...
Could you go back?
Yeah, she can, I can.
3.6 million years. Is there organic rich shale in that section right there?
Which, with the 90...
Right there.
Or right around there, there is. There are very organic rich intervals that are present in Big Bend right around the Cenomanian Turonian boundary.
Total organic carbon content that is in?
There's some people who have been on field trips who know the answer to that. I do not right
We
now.
have not done.
We have not done total. What has happened in the Big Bend area is because of the tertiary intrusions, the area got heated up really beyond the liquid and the gas window. So all you see are these little black, thick, organic-rich horizons that remain. Okay, so basically the geothermal gradient, because of the tertiary igneous activity, drove everything off.
Well, as I understand the concept, that's pretty significant for carbon.
Oh yeah, I'm just saying if there wasn't any tertiary igneous activity, Big Bend would be extremely interesting from a oil exploration point of view.
And we weren't looking for oil. We are.
Hard to believe. We were looking at the rocks.
I know, but if you're looking for
It is
oil,
part of the basin type development, though, that was important in terms of the Maverick Basin area, the Eagle Ford, though. there's still a story out there. It's just there's no hydrocarbons. Okay, so there is evidence of organic deposition occurring there. At the top of the
And there are geospace there.
At the top of the Ernst member is the red line there that is the Allocryoceras hazardi zone,
My discovery.
and it's shown here in red, and basically this is what this presentation is more or less focused on. Okay. This is the correlation of the Boquillas Formation in Big Bend with the area along Highway 90 that has been described by Locke and others in 2010, and Donovan and Starker in 2010 also. And this is sort of a best fit correlation we can come up with. The Ernst member corresponds to the Eagle Ford Formation or Boquillas flags in the Del Rio Langtree area, to Sanderson, and part of the Eagle Ford Formation as defined by Donovan and Starker. And they put in the Langtree Formation, and so the red line, 95.03, that's basically Oceanic Anoxic Event 2 along the Cenomanian-Turonian stage boundary. And then at the Allocryoceras hazardi zone is basically at the Turonian-Coniacian stage boundary based on index identification of index fauna in this area. Okay, let's go on to the correlation. Okay, this is the correlation of the stratigraphy in Big Bend National Park with that has been identified in the Maverick Basin in a general way. The 4 oceanic anoxic events that occurred during the lower and upper Cretaceous are shown here by the red lines. The big difference here is that there are more units, and the first 2 oceanic anoxic events appear at the top and bottom of the Pearsall Formation, and of course they have been productive also from an oil company gas point of view. And of course they are not present at all in the Big Bend area. It's just an angular unconformity. And then the Cenomanian-Turonian OAE2 there, which can be identified in both the Maverick Basin and Big Bend. And then Oceanic Anoxic Event 3, which covers sort of 3 or 4 million years, but it's sort of in the lower red dashed line represents the position of the Allocryoceras hazardi zone.
Notice the difference in thickness between the Eagle Ford and the Austin Chalk and the San Vicente and the Ernst.
The San Vicente and the Austin Chalk are very similar. There's only about 5 meters of difference in terms of their thickness. But the Maverick Basin area is significantly thicker, up to 50, 60 meters thicker in places. Let's go on.
I feel bad about this USC. I just knew we'd fail.
Well, we need to get to Doug Silva is who we need. He's the one that...
Yeah, we got to get some of those industry people to
Okay,
help us.
yes. Okay, this is sort of shows the Boquillas Formation relative to global sea level changes. And the red line shows the global sea level curve. This is taken from Miller and others in 2005. So this is based on Miller. 0 represents modern day present sea level. And you can see that as you come up through the Cenomanian, there was a marked transgression that coincides with Oceanic Anoxic Event 2 right near the Cenomanian-Turonian boundary. There are several regressions, transgressions in there. And then as you get into the upper part of the Turonian, upper part of the Ernst member, there was a Ernst member.
I'm sorry, where am I?
Right there, right there.
Here,
There was
okay.
there was an overall regression. There were some sort of minor transgression in there, but it was an overall regression, and that regression reached a maximum retreat right at about 88.6 million years ago. The blue dashed line represents the Allocryoceras hazardi zone in that iron-bearing interval.
And see, another thing that's about this zone is it's not thick. It's easy to identify, as he's going to show you. So it's a great isochron.
So the San Vicente member, which is the lateral equivalent of the Austin Chalk and the Niobrara Formation all over Kansas, Colorado, those areas, is shown in the yellow here. And the units that we've sort of defined, I guess I'm to blame for that. The massive limestone units were deposited near the base of 1, 2, and 3 were deposited during transgressions. And then the upper part of the 1, 2, and 3, which are carbonate muds, were deposited during the regressions. And this matches up very well with the global sea level curve and changes in the global sea level. And then the benthic foraminiferal delta 18 oxygen data, this is also from Miller. But it sort of shows some of the incursions. Moving back to Big Bend. It's cited in the guidebook anyway. Or email us. Okay, back to Big Bend National Park. This is a photo of K-Bar, which is researcher housing in Big Bend National Park.
It's an old farmhouse that was left back when the park was designated a park, or an old ranch house.
They were basically bought out. It was an eminent domain type thing. They just bought up all the ranch land that is now part of Big Bend National Park. On the middle distance, you'll see sort of some black peaks. That is Roy's Peak, which is part of one of these tertiary igneous intrusions, which caused so much problem from a oil perspective point of view. On the little bit further back is a feature called the Alto Relax, which is the little white lateral stripe there is basically the Santa Elena limestone. And basically, if you look real close, you can see it tilts over, and it's actually a laramide-related feature. It's a very gently plunging anticline in there. And then on the skyline is the Sierra del Carmen on there.
Which is in?
It's in Big Bend. As soon as you get across the top of the Sierra del Carmen, you're on private land, pretty much. Anyway. There's basically just 4 rooms in here. There was a bathroom that was installed later. The little building adjacent to it is the old garage for a Model T. The ranch house was built in the 1920s, and it's quite remote. And like I said, just because it sits down in a pocket, there is no cell phone. Well, you can put a telephone in line if you want to. I like the... I'll tell you, the greatest days I've spent in the field in Big Bend were when I was all alone here at K-Bar. Go out and do my field work, come back. I was all by myself.
Because the other research, up to 6 can stay there. So you try to oh gosh, we're all alone. Walk around naked in the house.
Yeah. Anyway, all types of researchers stay here. Biologists, herpetologists. Any biology you can think of, they've stayed here at K-Bar. Texas Tech has a lot of research that they do using K-Bar as sort of a basis of their operations.
Other research locations.
Botanists,
this is Roger's favorite.
Botanists and all that type of thing. Basically what you see in terms of vegetation in this area, which actually has not the highest elevation, but it's up around 4,000 to 5,000 feet. Prickly pear and mesquite bush, or greasewood if you're more familiar with that term. Creosote bush or greasewood.
Mesquite is not.
Greasewood is another term that's used.
Greasewood is creosote.
Okay, let's go on. This is a scenic view in the southern part of the town. On the hill, on the sort of the skyline there, that's the Butte Formation, and it's a laramide-related asymmetric fold. You can see the east side on the left side is much steeper than what it appears on the west side. And the brown area that's in Mexico, that is actually in Mexico, that is the Ernst, or the Eagle Ford equivalent. And in the foreground is the San Vicente member, the alternating massive limestone marl units and carbonate sort of mud units, and you can see that the scrub greasewood, it prefers the carbonate mud a little bit to the limestones are pretty much barren. And so the Rio Grande goes between the foreground, the white stuff, And I think you can get a little glimpse of the lower part there if you look during that little V notch. Go back, go down to the left, right there. You're looking basically down towards the Rio Grande right there. And you can wade across it here. I mean,
But you
no
don't
problem.
want to do that.
I never waded across because it's not
people-
good territory to be wandering
It's not
around in
safe.
Mexico.
There's
There
people
are.
on the other side.
There's a lot of illegal things that go on in this area. But if you wanted to find the Alocrioceras hazardi zone, you can almost pinpoint it right at the top of that brown stuff there. If I could go across into Mexico, it would be there. I could see it with binoculars. Okay, the Alocrioceras hazardi zone. This
Looks
is,
like this. Everywhere you see it, it's a brown stripe.
as long as it's gently inclined, it forms a very distinctive brown marker. You can trace it almost anywhere.
And you can go to this right from the highway along, what is it, 385, 285.
385.
385.
This is 9
Where
Point
you
Draw.
stand there and there's a sign about the camels that were kept in Dog Canyon. These little cuestas are right there. You drive to the little primitive campsite, which is down over here, and you don't have to hike or do any great distance at all to get to this location.
And one of the things,
Back here is the famous dog. Well, the Dog Canyon is actually over here.
the Alocrioceras hazardi zone, an enclosing iron-bearing interval, is only about 1 to 3 meters thick, but it's more resistant to weathering and erosion, and so you can see the talus and debris that just sort of covers the hillside there for several meters below the actual iron-bearing interval. Okay, this is another exposure of the Alocrioceras hazardi zone along Tornillo Creek, and we've put on the
Near
Ernst
Desert
member.
March locality.
This is just east of the Death March
That's
where
you
it
go
started.
to do it, though.
Anyway, this is the iron-bearing interval is sort of defined there, the Alocrioceras hazardi zone itself, and then the overlying San Vicente member. So this iron-bearing interval sort of brackets the Turonian-Coniacian stage boundary.
Which is what makes it such a great marker bed, because you can see the brown. You can't see it quite so well in this picture, but you see how it's a little browner than the stuff above and below.
Okay, this
Here
is,
it is without decor.
Yeah.
You see how it's browner?
and you can pick out the number. Let's go back. You can pick out what I referred to as the number 1, the number 2, number 3, and the number 4 indurated intervals within the Alocrioceras hazardi zone. You can see that the iron bearing extends about 1 meter above that sort of slight little ledge there, and about 1 meter below down into the Ernst. And another picture of this, a little bit further away. This is what you commonly see in the field in various places. You can see just a little sort of break in the ridge line there, and that is the top of the Alocrioceras hazardi zone. And you can just follow it right down the side here, and this is Tornillo Creek in the foreground. If you look on the skyline there off in the distance, that is the Sierra del Carmen in Mexico. So the Rio Grande is within 100 yards or so of this particular shot. So it is also described in the guidebook. Okay, we estimate that the sedimentation rate, let me back up. Okay, this is a very general lithostratigraphy column of the Alocrioceras hazardi. The indurated intervals are 1, 2, 3, and 4. They are separated by iron-bearing carbonate mud. I'm on slide 17. Stay with this, stay with this. And each of these upper 3 intervals, which is really unique, has a very 5 to 10 millimeter thick interval that is on a fresh surface. It's very fine-grained disseminated pyrite, which weathers to limonite and goethite, and you can find these red layers. You know you aren't very far from your objective when you're mapping them, when you find these pieces of the allo zone that have the red layers in them. And basically these, the indurated intervals are basically calcarenites that are layered on a 1 to 2 centimeter scale. And the carbonate mud shown in sort of the tan color, they're laminated on a 0.5 to 1 millimeter interval. Some of them form sort of layers in places, but they aren't really distinctive enough to follow for any distance laterally. And the layering, the graded layers, the 1 to 2 centimeter graded layers, often have sort of what you'd call undulatory bases and tops to them, indicating that there were actual currents there. So often in the 1, 2, 3, and 4 darker brown areas, you see sort of shell fragments that grade upward into a silt, even a shale or mud-sized material. We estimate that the deposition rate was about 1.2 centimeters per year, which means that the Alocrioceras hazardi from bottom of 1 to the top of 4 here was deposited in about 105,000 years, which would put it on track with some type of Milankovitch cycle. Entire iron-bearing interval, we think we would estimate at 1.2 centimeters a year would be about 260,000 years, which would also be another type of Milankovitch cycle. This is the type locality. Again, this is what you typically see in the field of it. You can see 1, 2, 3, and 4, the interbedded carbonate mud, very distinctive. And in the upper 3 there, I've tried to point out the pyrite limonite, these very distinctive red markers. So the disseminated pyrite suggests there was actually primary deposition of iron sulfide when they were accumulating. Okay, the Alocrioceras hazardi zone has been mapped from south of Solis Landing right along the Rio Grande there with the black dot with the A next to it, 45 miles north to the O, just south of Persimmon Gap a ways. I have walked this distance at least 4 times. Some of it I've walked 7 or 8 times because of the inaccessible nature of some of these areas in here. No off-road vehicles are allowed in Big Bend National Park, so once you leave any type of road, you're on foot. No ATVs to run around in. The park rangers will be very nasty to you if you take an ATV out there.
How about a bicycle?
No,
not off the road, not even a bicycle.
Oh, yeah.
No matter how you rig up your bicycle, they won't allow it on any off-road area at all. Everything's on foot.
On foot.
And
this is where I over here a bit.
in
He's the mapper.
other mappers in the past have used air photographs or satellite imagery to map some of these more inaccessible areas. And the problem is that the colors of some of the units are exactly the same. The Del Rio, which is a brown unit, looks exactly like the lowermost Ernst part of the Ernst member, and so there was a lot of misidentification of rock units based on air photos and satellite imagery. So there's a lot to be said for ground truth. Okay, let's go back real quick. Okay, if you go from A to O, the next figure shows a long section or cross section of the Alocrioceras hazardi over a distance of about 45 miles. See how remarkable and consistent the Alocrioceras hazardi zone. This suggests that this unit was deposited on essentially a flat, featureless environment to have this remarkable consistency over about 45 miles. If you look at the iron-bearing interval, which goes all the brown, lighter brown, all the way up and down there, it shows a little bit more irregularity, and this is why we think that there were disconformities at the base and top of the iron-bearing interval. This was right in the middle of that cross-section there.
Where that camp is about in here.
Yeah, a little bit further north. K or L, right up in there. Is right up in there. This was the camp I had during the summer of 2005. Roy's Peak is in the background there. And I can say that it was one of the hottest summers they've ever had out there. It was
It's
100.
just a hot hellhole. There's no. It's like the worst primitive campsite in all of Big Bend National Park. He decided.
I put up the canopy to get just a little bit of shade. And there are days when I was out in this area when the rocks were too hot to sit on at 10 a.m. in the morning. You quickly learned to carry a towel with you so you could put it down on the rocks and you wouldn't roast anything.
Because we had to teach. We had to teach. That's why we went this summer.
Okay, in this area,
But you're also alone. You don't run into a lot of tourists.
I did most of my
They're smarter.
most of my mapping I did alone. So if something happened, well, that's what happened. Some of the vegetation in the camp area is a candelia. It's actually a waxy plant. It was used to make wax by some of the early settlers in
Boil
the
it,
area.
and the wax rises to the top, and you
One of
spin
the-
it to make candles.
One of the most ugliest plants is Lechuguilla.
Hurtful.
No, it's not purple. It's the green arrow-like stuff.
Hurtful.
Hurtful.
The
Basic.
tip of the Lechuguilla is slightly poisonous, and the tip comes off in your leg and turns like a cotter pin, so it's sideways. So it's hurtful. It's
If
there
you-
are more
if-
hurtful ones.
If you don't get
What I
Lechuguilla points out within about 5 minutes, you're going to have a brown spot for a long, long time where the needle finally starts to disintegrate. It actually burrows its way in.
It's bad.
Anyway, you don't want to fall in a pile of Lechuguilla. That's
And
one
then
of the
there's
last.
some creosote here.
Creosote and greasewood
Good
also.
stuff, no spines. just
No
good.
shade. Keep that in mind. No shade. There's no water source near here at all.
Then we
Haul it in. You haul it in. I
He
knew
was out here doing this, and I was bringing him a restock, because I don't do it this much anymore.
from this particular location, you had to drive about anywhere from 5 to 10 miles to find water sources.
No, you don't drink the
Which
wild
were-
water out there. You don't.
Well,
You
I-
don't.
Well,
You might have.
you do what you have to do.
We didn't ever have to do that, except, and you put iodine in it if you have to.
Okay, in June of 2008, there were 3 people who came across illegally from Mexico and followed an old road, which is right next to this campsite, that was used to transport lead and zinc silver ore from in Mexico to the railhead at Marathon, about 90 miles to the north. They passed right where my green Jeep is parked there, and they only had 3 gallons of water with them. Rio Grande Village, where they crossed, was about 17 miles away, and they all died of heat prostration.
People who are not prepared.
If you want to read about what happened, there's a book called Death in Big Bend that's
Yes.
the Park Service has. It's a very good book.
And we
If you want to know about what happens to people. And basically, the vacuolites, I'll just sort of start in the upper,
all see, this is a heteromorphic.
This is a
They're
heteromorph-
just straight.
and then you have the Allocrioceras hazardi,
The loosely coiled dude.
what is called Scaphites semicostatus.
That's the G-shaped ammonite that's on the cover of the textbooks, but you never ever really see one. Well, there they are,
And-
boys and girls.
And one of the more unique finds was a belemnite, some variety of squid with actual soft body
See the
parts
tentacles?
preserved.
See that? Roger found that. I was so jealous. And his daughter, Roger and his daughter.
And basically, this nectonic fauna, heteromorphic ammonite fauna, makes up about 73.6% of the identified fauna.
And then there's these little sessile inoceros
And then the
guys.
Cremnoceramus deformis erectus is the index invertebrate inoceramid for the lowermost Coniacean, and so there's a lot of those there.
This is how we know we crossed the stage boundary.
Yes.
When you go from the evolution of one of these to the other. So they evolved in like a 2,000-year period.
Okay, and the Cremnoceramus deformis erectus is the primary sessile or benthic fauna that you found, or can be identified in Big Bend.
They're kind of like oysters, but
The
they're
other-
not ancestral to oysters.
The other unique thing in terms of that is we have found one, and then there's been some other fish that have been found, but no large predators. We've never found any large evidence of any large predators. Okay, going back to the Paleo Environment here, and again, this is the same picture that was very early on, and it has a cross-section from the Chihuahua Trough to across the Maverick Basin, out into, whether you want to call it the Tethys Ocean or whatever at that period of time anyway, out to there. And basically the yellow, where the Allocrioceras hazardi and the top of the Coahuila block is basically lagoonal carbonates and mud in the shallow water. Then you had the shallow shelf carbonate shown in the very light blue, and then the lower shelf and deeper marine shown in the darker blue. And again, the green arrows are an estimation of what may have been going on in terms of surface current activity. And this is that cross section, very schematic, very simplified as to what we think things may have looked like at the Turonian-Coniacian stage boundary about 88.6 million years ago.
And what's already happened.
And so you have the Edward Stewart City sort of margin, reef-type complex in there, and then you sort of work your way down into what the Maverick Basin area, which, as I was talking with Terry about a little bit earlier, I think was a persistent low through older lower Cretaceous units as well as the principal lower Cretaceous units as they're identified on this cross section. And then you have the Tyrell Arch, which the Boquillas Formation, Eagle Ford, does thin over the Tyrell Arch.
This is kind of where the name to the formation.
That's where Langtree, and those of you that have been there, Langtree is, Lozier Canyon is all right in there. And then you get further to the west, you get into the Big Bend area where the Allocrioceras hazardi zone was deposited in, I think, a very shallow, very isolated bathymetric high environment that sloped off into the Chihuahua Trough to the
They were like a
west-northwest.
lagoon on top of an atoll
Yeah.
by the
And
time they got isolated.
This is why we think that the Edwards, Georgetown, Santa Elena, Del Carmen shelf margin rocks were so important to the development of the isolated fauna at the 88.6 million or so years ago.
And please notice this is a
It's
600
600
mile
miles.
cross section. There will be people who don't agree with
I
it.
think some of the earlier rift-related faults that were basically Triassic and Jurassic age, I think some of these propagated up into the lower Cretaceous. Can't really prove that, but that's what I think may have happened, which also would have helped to keep this area sort of elevated during much of the Turonian-Coniacian time. And of course, everything got wiped out then when you got to the Austin Chalk, San Vicente Formation deposited. It just obliterated all this sort of
With the
bathymetry.
transgression. What happened here? Was that the last slide?
That's the last slide.
Okay, sorry. So,
Thank you for your
what do you
time.
think?
Let's go.
Except for the COC, really, we could use industry help. Yes, ma'am.
Both of you a rock. It's a piece of Carrara marble from Carrara, Italy.
Oh, that's really nice.
It was deposited in the Triassic-Jurassic period, metamorphosed in the Oligocene, and exposed at the surface during the retreat of the last glaciers. The Romans mined it to make their baths. Michelangelo carved
I
in
was
it,
just going to think, I was thinking of Michelangelo used it.
and the HCS uses it as a paperweight.
Well, I'm happy.
So thank you for coming.
I got yours, you have mine. Give it back. Got our name.